Hello everyone. So let us continue with the next problem. So it is using stiffness matrix, analyze the given frame. Again, nowhere in the problem they will give you whether it's a sway or a non-sway. So it's a simple non-sway frame. Now how we can analyze this is, now you can see here A, B, C and D. Okay, so it is all symmetric. So if you cut this across, only this frame is symmetric. Okay, and then addition to this there is a hinge. Okay, so there are no loads acting horizontally, and even the height of the column is same. So it's a non-sway frame. It was not swaying in either right or left direction. Okay, so now again because it's a sway, again the formula that is ki is equal to 3j minus r plus m will not hold good. So you have to just check out with each and every joint and then uh, plot the degrees of freedom. Okay, so now again A and D are fixed. Okay, A and D are fixed. That means they cannot move horizontally, vertically, or they cannot rotate. A and D. So the next option here is B and C and E. So B, C, E and E are they are hinge supports. So because they are hinge supports, they're restricted in horizontally and vertical movement. They're restricted horizontally and vertically, but they can move in the third direction. So the third direction is this thing. Okay. So here B is the coordinate direction 1 degree of freedom. Then C is second degree of freedom. Then 3 at E is 3, that is third degree of freedom. So we'll mark like this. So degrees of freedom is 1, 2 and 3. Okay. All right. Next, AB, BA, MF, CD, DC, MF, CE, CE, EC, all are 0. So the moment only which exists is MFBC. So MFBC is minus WL square by 12 and MFCB is plus WL square by 12. So we're written here. Okay. Next, calculate P1L, P2L. Okay. So P1L, first coordinate direction. 1L is nothing but it is MF first direction. So it is only MF BC, first direction. Okay. 1L, 2L, and 3L, all three direction. Okay. So 1L is MF BC, only this portion, MF BC, this portion. Okay. So MF BC is equal to minus 120. Next, in second direction. So in second direction, it is in two different portions. That is MFCB, MFCB, and MFFCE. So in second coordination, MFCB, MFCE. So MFCB is minus 20 and 120. MFCE is 0. Okay, and in the third coordinate direction, in this direction. Okay, third coordinate direction. That is nothing but MF third coordination direction. That is MFEC. So MFEC is 0. Okay, we're not written here, but it is 0. Okay. So once you write this P1L, 2L, 3L, next is we find out, we'll sum up PL here. That is minus 120 plus 120, 0. Okay. P here is, see, nowhere in the frame there are moments, end moments, applied extra end moments in A, D or E. There are no end moments. So because there are no end moments, this P1, the P1, P2, P3 will be 0. Okay. Next is, once you find out PL and P, then is stiffness matrix. So stiffness matrix is apply a unit displacement in coordinate direction 1. Okay, so apply unit displacement in coordinate direction 1 here, this portion. So we apply moment here in this portion. So you can notice, apply theta B is equal to 1. So AB and BC are affected, right? So in AB, so it is, you can notice here, this is BC. If I apply a clockwise rotation at B, BC will bend downward. That is first thing. So this beam will go downward. So it bends like this. Next is the same moment tries to push BA to the left side like this. It pushes like this and goes on top. Okay. So that's why this will bend. Again, you can notice bend portion is more here. And as it comes towards the fixed support, it goes on reducing. You can see it will be straight up to certain portion, then it bends. Here also it bends. Okay, all right. So once you mark this, next is one marking. This is very important. That is deflected portion of the beam. Next is 1, 2, and 3 direction. So K1, K2, K3. All right, K1, K2, K3 is the rotations applied. Next, uh, because you're applying theta in the first coordinate direction, then it is like the second 1, 1, and 1. The second number you write like that. So first write K1, K2, K3 because these are the rotations in the first direction, second direction, third direction. Then the second number indicates where you have applied the rotation. So you have applied rotation in the first coordinate direction. So it is 1, 1, and 1. Okay. All right. So once you mark this, next is find K11. So K11, you can see this. This is K11 is nothing but MBA. Because you're applying this rotation, AB and BC are affected. So it is like MFBA and MFBC. Again, be careful when you're writing this MFBA. So MFBA is not as equal as MFAB. So start from where always the joint from where you start. That should be the first point. So that is MFBA plus MFBC. So it is 2EI by L. Then 2EI by L. So it is next 2 times theta B plus theta A. Again, you have to fix all the joints, only release the joint where you're applying the rotation. Then similarly, MFBC 2EI by L. So 2 times theta B plus theta C. So K11 is 1.34 EI. Okay. Next, similarly, K21. Okay, in K21, only BC is deflected. Only what is getting deflected, for that you should write the formula. Okay, so here it is MFCB. So MFCB is equal to 2EI by L. So again, C is the first term. So 2 times theta C plus theta B. Then write K21. Okay, so K21 you written. Next, similarly, K31. Again, in this part of the beam, nothing is affected. Because nothing is affected, this would be 0. Next, similarly, apply unit displacement theta C is equal to 1 in coordinate direction 2. Okay, so now release joint C, fix all the other joints A, B, D, and E. Then apply theta C is equal to 1. And then check what all rotates. So because C is connecting B, it is connecting B also, CB, CE, and CD. So all the three members will deflect. Now, because all the three members will deflect, so you have to write it as theta C is equal to 1. Okay, theta C is equal to 1. Then apply a clockwise moment. When you apply a clockwise moment, so this will bend. Okay, CE will bend downward. Then, because it pushes this column to the left side, CD will bend, and then again it goes and pushes this beam upward. So upward movement, downward movement, and this is a left side column rotation, column movement. Okay. So once you draw this deflected shape of the beam, then mark again K1, K2, K3. First write K1, K2, K3 as usual in the coordinate directions. Okay. Next is mark, because you're applying the rotation at coordinate direction 2. So this would be 2, 2, and 2. So it would be K12, K22, K32. Okay. All right. So right here. So mark again. Once you mark that, find K12. So K12 is MF. K12 is MFBC. Only this portion. 1, 2, only this portion. Take this portion of the beam. So K12 is MFBC. MFBC is equal to 2EI by L. So 2 times theta B plus theta C. Next, K22. K22 is MFCB, MFCD, and MFCE. All three. So MF, because it's connecting all three members, and all three members are getting deflected. So it is 2EI by L. So 2 times theta C plus theta B, then plus 2EI by L, then here 2 times theta C plus theta D, and same in this portion 2EI by L, 2 times theta C plus theta E. So all other joints will be B, D, and E will be 0. Only theta C, wherever there exists theta C, you have to put the value 1. So solve this, you'll get K22. So K22 is 2.23 EI. Okay. All right. Next, the final one, K32. So K32 means it is from the span. So CE. So it is MF EC. So MF EC is equal to 2 EI by L. This is the first joint. So it is 2 times theta E plus theta C is equal to 0.44 EI. That is K32. Okay. So after this, let us go to the next last coordinate direction. That is third direction. Apply unit displacement theta E is equal to 1 in coordinate direction 3. Okay, coordinate direction 3. Okay, now then fix all other joints A, D, B, C. Only release E. Okay, only release E. Next, once you release E, then it is uh, fixed all other joints, release E and put theta E is equal to 1. Okay, put theta E is equal to 1 radian. So now when you apply a rotation here, so what happens? It tries to push CE upward. So this portion of the beam goes upward, this portion like this. Okay, then what you have to do is mark again K1 first direction, K1, K2, K3. Write this as K1, K2, K3. Okay, after this, because you're applying theta in the third direction, so you have to write 3, 3 and 3. Okay, so it is K1 3, K2 3, K3 3. Wherever you're applying the rotation, the second number indicates that. So you're applying rotation in the second part here, that is in the uh, coordinate direction 3. So you have to write this as 3. So first always write this as, to make this simple, write this as K1, K2, K3. This will be fixed no matter what. So wherever you apply the rotation, only the second term will change. So we have applied in third coordinate direction. It is 3, 3 and 3. Okay. All right. Once you mark this, next is right K13. So K13 here nothing is getting deflected in this portion of the beam. Okay. So K13 is equal to 0. Next K23. So it is K23 is equal to MFCE. So MFCE is equal to 2 EI by L, then 2 times theta C plus theta E. Okay. So again theta C is 0 because it's a fixed support. So write K23. Next, K33 is equal to MFEC. K33 is MFEC, which is 2EI by L, 2 times theta E plus theta C. Okay, so K33 is equal to 0.89 EI. So once you find out all the K values, next is use the stiffness matrix equation to find the delta values. So the stiffness matrix equation is given K into delta is equal to P minus PL. So here also same thing. Okay, so again here they have we've used this one textbook method wherein they have used such formula. So you'll better you write it like this: K11, K12, K 13. Okay, K11, K12, K13. Then this also K21, K22, K23, K31. Okay, K31, K32, K33. Okay, write this like this, and then write substitute the values. So here again the values happen to be same: delta 1, delta 2, delta 3. This is again we have already calculated this P minus PL. Put this here. And then take out the common value. So it is 1.34. So here these all will remain fixed. K1, K13, 1.34, 2.23, 0.89. Okay, K11, K22, K33. Okay, only these are same here. Here 0.33, 0.33, 0, 0, 0.44, 0.44. So what we have written here, okay, again, luckily it is going to be symmetrical. That's why no much changes here. But what you'll do is you'll don't write the formula like this. Just remember one thing. So the first number indicates row, second number indicates column. Here also. So it is second row. This is like a row, right? Second row K21, K31. Write it like this only. Just flip this and write. Once you mark this, then delta 1, delta 2, delta 3. So it is 1 by EI. This portion comes here. So it is this matrix inverse into this. Okay, so it is theta b, theta c, and theta e here. Okay, three unknowns. Theta is unknown. So put it in the calci and solve. Again, this would be a 3 by 3 matrix. Again, I've told you how to solve this using the calci. See the previous two videos. I've explained step by step procedure how to put it in the calci and solve directly. Okay, once you solve this, then find this is like mat A inverse mat B. Mat A inverse mat B. So this would be once you solve it in the calci, this is theta b, theta c, and theta e. Okay, then once you calculate this, so calculate the final terms here, that is mab. So mab is, again put the same slope deflection formula. Mab is equal to mfab plus 2ei by l, then 2 times theta a plus theta b minus 3 delta by l. That is first. Next, mba. Mba is equal to mfba plus 2ei by l, mfba plus 2ei by l, then 2 times theta b plus theta a minus 3 delta by l. Calculate like this and on up to mec. Calculate, put the formula and calculate all the moments, final end moments. All right. Okay, that's all for today. Thank you.